Right, so I'm going to talk about test-driven development for Puppet. First I'm going to talk about who I am. I'm Gareth on Twitter. I work for the UK government. So if you're a UK citizen, you pay me my wages. Thank you. I'm a civil servant. I also publish a weekly newsletter called DevOps Weekly. If you're not on that, you should be. If you are, you get an email from me every week. I'm a pretty frequent contributor to Forge modules, and a lot of what I'm talking about here is sort of based on experience of writing and publishing and collaborating with lots of other people on shared modules. Because I think there's sort of a problem. And it's true of sort of even some of the better modules, but actually there's a barrier to entry to getting started. This isn't a rant. So, who here is a software developer? That's a good number of hands. That may be 50, 60% of the hands. I think fair. Wrong. So, the people who put their hands up are correct. The people who didn't put their hands up are wrong. If you're writing Puppet code, you're a software developer. Puppet is code. It's software you're writing, and sorry about that. As a software developer, it's your job to learn software engineering practices. And this turns out to be brilliant. Because actually, lots of people are coming to sort of code through Puppet. They're going, wow, this is a great tool, this is a good thing to do, this is like, I can do a lot more with it. But it's hard, there's a barrier to entry there. There's a lot of tools, there's a lot of terminology, there's a lot of things. Turns out there's 20, 30 years of software engineering practices that we can steal from. We should do. One of those practices is test-driven development. And I'll hopefully explain what that is, like why it's a good idea, show you some examples, and eventually there'll be some Puppet code, I promise. So test-driven development is a software engineering practice. It's pretty common. It comes up in sort of XP, so extreme programming terminologies. It's not just testing. So testing is good, writing tests, writing unit tests, writing acceptance integration tests, writing different types of tests is a good thing. Test-driven development is more than that. It's not quite the same thing. The idea behind test-driven development is that it encourages simple designs and inspires confidence. And that's not my words, I stole them from, I think, Kent Beck. The idea is actually really, really simple. First, write an initially failing automated test case. So this is before you've written some code. You have an idea, or someone's given you an idea, or someone's given you a job to do. Before you do that, before you do the thing to do that, you write a test. It's obviously going to fail because it's the first thing you've done. Then, your job is to produce the minimum amount of code to pass that test. And what's the smallest way of solving the problem that you've described in code? And this is the bit that lots of people forget about, and then move on to the next bit, is and finally refactor the new code to acceptable standards. Because ultimately, the fastest, shortest route to a solution might not be the best one. It's incremental. It's over time. You build up the actual tests and the code. But because you're not diving straight into the code, you're first having to describe in code, in an automated test, like the behavior you expect. It's forcing you to design your code before you write it. And that turns out to be really important and really useful. Test-driven development is sort of, some people say it's not test-driven development. You'll hear TDD. Actually, some people say it would have been better off, and it's probably too late now, but basically to say it's test-driven design. Because actually, it's less about testing and development and more about designing your software. There's a really good book, this is a canonical book on test-driven development. It doesn't matter that it's not about Puppet, it doesn't matter that it's not about a language you might care about. It steps you through, like, case by case, in a sort of very good way, what this is, why it's useful, how to do it. Loads of patterns. This is an introductory talk to doing some of this in Puppet. That's a really good book. It's a bit of a classic of software engineering. Again, there's loads we can steal from the software. Unit testing with Spec and Guard. You might not know what those are, that's fine. Unit testing is one type of testing. and we'll sort of start there. And in this sense, a unit is the smallest testable part of an application. So think small. It's not about testing the website. It's about testing that function that does something that contributes towards the website. In Puppet, it's not about testing your entire module. It's probably about testing the behavior of a class or something like that. Testing Puppet requires a little bit of Ruby knowledge. Sorry about that. You might not be a Ruby programmer. In order to really build good, shared, sort of reasonably complex Puppet modules, you're going to have to become one. There's not much to it. If you can program in other languages competently, you can pick up the amount of Ruby you're going to require to become good at testing Puppet code. So I'm doing these first examples in Ruby, but they could be in any language. So, again, this is in Puppet. We'll go to Puppet later. This is a class. This is a Ruby class. This is a class of a person, and there's a method that says something. There's no implementation of that, but that's what we're talking about. So that's basically, I sort of wrote some code, but it doesn't really do anything. It's not really code. I told you to implement a person in code, and you got there to start with. But first, let's write a test for this using the Spec testing framework. So require person is just boilerplate. We're just saying, well, grab the code about the person. And it's this describe block that's interesting. So describe person say, so it's basically describe the same method on person. It should say something. So we're starting to describe in code what the code we're going to write should do. And let's fill in the implementation. So, well, Bob's a person, Bob's a new person. If Bob says hello, then that say method should return, so should equal hello everyone. So we've described in code a test for our code we haven't written yet. Now let's run our test. So Spec's a tool, it's a Ruby tool, and we can run our test, and we get some output. And it failed, which is a shock because we haven't written the implementation. And we get some details about, and again, very fast, it's very simple. It tells us it failed, we knew that was going to happen. Now let's go back to our class and write the implementation. And this is a very simple example. This is just from first principles, there's nothing before this. In reality, you'll probably most code you write isn't from a blank slate, it's from inside an application. So this is obviously a somewhat contrived example. The only difference here is we've got this, say, word plus space everyone. So what we're going to say, when that's the simplest code we could write to pass that test. It's not. And we're going to spot the gap. And run our test again. So this time it passes. I'd say very simple, very contrived example. Doesn't matter if you're not following the Ruby code, but that's the process you go through in test-driven development. And you do that over and over and over and over again until you get to your solution. But actually, that's a bit boring. Jumping between these two things, jumping between these three things, we're jumping between our test code, our code, and hitting a command line to run a test feels a bit going around in circles. There's things that can help there though. So why not have tests automatically run whenever you change the code? And that might be you change your code, or it might be you change your test code. There's a handy tool called Guard that does this for you. Again, Ruby tool integrates really well with Spec and with the sort of Ruby testing tools. Actually, it's useful for all sorts of things when you want to see that something's changed and do something. But a very simple Guard file. Everything has to be like a Word program file, Puppet file, gem file, etc. You have a Guard file. Few lines of code, and actually what this is doing is it's watching the spec folder, or it's watching the lib folder. So it's watching the tests, or it's watching the code, and it's going to run bundle exec rspec in my case, but basically that's running the tests. Once you've got that file in place, you just type guard, then it'll go. And that's all a bit theoretical, so let's make this a bit bigger and look at an actual live demo. If I can work out how to get my cursor over there. Is that big enough at the back? So, over here, bottom left, we've got our person class. Over there, oh, sorry, that's our test. That's our class. So, let's go up here and type guard. That'll take a second. That's now running. So if I change, hopefully, anything down here, that should automatically pick it up. So I changed the test because I want something different to happen. Let's see if I change it. Instead of everyone, I want my code now to say puppy cam. So, oops. So instead of it saying that,
you're missing two.
yeah. That. And it's passed. So actually, this is very sort of, this is the sort of workflow that I would tend to use, whether I'm writing some Ruby code and we'll show Puppet in a moment. But again, I'm looking at my code, I'm looking at my tests, and my tests are automatically running whenever I'm changing anything. I'm getting automatic feedback that I'm heading in the right direction. I'm also designing my code ahead of writing it. There's my cursor. So, that's a very, very, very quick introduction to writing tests in Ruby. You're not going to be an expert to start with. You only need to know enough to get started. But you do need to know a bit. Sorry. Why test Puppet code at all? You have to learn to program. This doesn't sound fun. It's a declarative language. Doesn't this solve this for me? Not really. Modules increasingly contain logic. It's not just class, file, package, done. Don't test those, that's not useful. But the moment you have an if, well, it does this on this operating system or this one on this, or you've got node definitions, well, it does something different on this node to this node. You're introducing logic, and it's the logic you need to test, not the declarative Puppet code. Modules increasingly take arguments. You pass things in, you say, well, that should be started or that shouldn't be. Oh, I want to use a different package name, I want to use a different repo, I don't want to use that upstream. Good shareable, reusable modules actually invariably have to take arguments, often provided by Hyro. What are able to be provided by Hyro? Well, how do you know that's working? You can test that. Modules increasingly have interfaces with other modules. Unless you have this one massive does everything organizational module, sort of mega class, you probably want to split that up. You can test these things independently, but they're going to have dependencies. Modules increasingly used in different operating systems and versions. Maybe not inside your organization, but maybe a third party when you're using it is, maybe something you've released is. Maybe something you're collaborating on across sort of a very large organization is used across multiple operating systems. Don't have separate modules for them. Have one and have the logic inside your module. In order to make that work, you have to test it. And modules increasingly are used in sort of, again, different Ruby, different Puppet versions, potentially in the same organization. But again, if we're ever going to get out of this sort of all writing our own Puppet code bases, which just feels very, very wasteful, we need to get good at sharing things across organizations that are not doing this, aren't all running the same version of the same operating system, the same version of Ruby, that's probably out of date, so the Ruby community won't support you, etc. So, I said I guess Puppet code. So, we looked at our Spec and we looked at Ruby very quickly. handily, we have our Spec puppet. This is a built on top of RSpec. It's using all of the same syntax. It's just basically a plugin. It's a library for RSpec that allows testing of puppet code. So this is basically a mirror image of what we've just seen in Ruby. Let's start off with something very simple. It's a puppet class. Hopefully by this point in the day, people are familiar with some puppet code. But this is pretty much the simplest example I could think of. So again, well, we've got, that's not real code, that's our class. First, let's write a test. So Spec helper here is basically just some boilerplate that we set up using the RSpec puppet tool. I'm not going through the installation of all these. The tools come with installation instructions, and I'll come on to a sort of shortcut in a moment. So describe, this describe block again, like saying what it is you're describing is exactly the same. Before we were describing our person, the same method on our person class. Here we're describing our sample class that we were talking about here. So, it should create file temp sample. Yes, it's code, but actually it's pretty readable code. So it being the sample class should create file temp like that. So that's a test that's saying, well, my puppet code should create a file at there. Well, if we run that, well, it doesn't, because we haven't written anything yet, so it fails. So now let's write our puppet code to sort that out. So puppet has a file resource. Let's puppet lint. There, so we can create something at temp sample, ensure present, run our test. It's going to pass because we've implemented the code against our design. Again, very trivial example. If you were really writing a class like that, that is just declarative. You probably don't need to do. But if that was wrapped in some logic, so sometimes it created it and sometimes it didn't, it's worth asserting on that to make sure the variable you're passing in that triggers that logic, or the fact that triggers that logic, is doing the right thing. And exactly the same as our Ruby code example, we can run this, running this manually feels like it just takes ages. If people are used to IDEs, well, they'll do some things like this for you. Geppetto probably does. I know Tmux and Vim guys, as you can tell. Instead of watching Spec and lib, now we're watching our Spec and manifests folder. So this is a puppet module. It's got a manifests folder. And whenever I change any of the .pp files in my manifests folder, this will trigger our test run. And let's see if we can do a quick example of that. So we've got, again, our sample puppet class. We've got our test, and we've got a garden thing, so let's run garden. So, what we could do, because we can test more than just the creation of files, we could test what the content inside is. So that's failed because, well, I haven't implemented the code yet, so I'm doing it the right way now this time. Okay. So you can see how over time, when you're building a puppet module, again, very simple example, but let's say I want to install a package. Let's say I want to do something different between different operating systems. Let's say I want to add a parameterized class and do things varying between that parameter. I can describe this in my text, and I can implement it in my code. And I can get constant feedback around that. I'm like, am I really doing what I think I'm doing? That's useful, I say, from this point of view of designing the module, deciding what behavior you want your module to have. It's also really, really useful when you come back to this module in 2 months or 2 years, and because you've got a description of what it does as well as the implementation. And even better, it's what about when your colleague comes to this module after you've left, or after you've been run over by a bus, or someone in a different country working for a different organisation because you've nicely shared this on the Forge or as open source. It gives you this sort of confidence that the features you're building into your modules are still working, very cheaply, very quickly. And that's the idea behind having those tests, having regression tests. Obviously there, just showing sort of like the create file sort of method in Spec. Very simple example. But we can test hosts, we can test defines, we can test facts, functions, hierarchy data. All of the things in the topic we can test. There's lots of examples, and nearly the best way of learning sort of like, well, what the tests look like, what are all these bits and pieces, is to look at some well-tested modules, and I'll come to an example. So there's other things we can do as well. As well as actually writing sort of like tests for behavior, we can do nearly sort of tests for style. We want to build a build process, it's not just about testing, it's about having that pipeline. Tom had sort of a very elaborate pipeline for his entire sort of infrastructure. Parts of that will be, well, is my code good enough? Parts of it is then, well, the code's good enough, but is the system you're building good enough? When it comes to the sort of like the micro bit of that around your Puppet code, testing it is part of it, or unit testing it, as we've been showing with Spec Puppet. But actually, Puppet lint is another tool. So people may or may not be familiar with the Puppet style guide. This is actually a really useful document, published by Puppet Labs, kept up to date, about, well, what's a good community standard way of like laying out Puppet code? And you think, well, why does it matter? Why don't we all just write different things? Again, it's all about us sharing. And the more we all write in different styles, using different brackets and braces and putting things all up online, calling things, different naming terminology, it becomes a barrier to sharing, a barrier to, like, and at some point you go, oh no, I'm just going to write my own. We need to get away from doing that, and the style guide really helps that. And again, stolen from lots of other good examples of software engineering. Puppet lint is a tool available as a Ruby gem that you can run across all of your Puppet code that can tell you where you're, and yes, you should read the style guide, but you'll forget bits of it. Having a tool that tells you where in your module you're doing it differently to that style guide. This isn't like testing where it's sort of working or not working. This is where you're doing something different to a standard. And that's not wrong or right. But the more you write code like everyone else in the room or anywhere else writing Puppet code, the more we can share. Sharing is good. Syntax checks are one of those things which actually, like, your code might be fine. Actually, you might have a bug somewhere in a template or in a YAML file, and they're just annoying things. Again, Puppet syntax is a tool written by one of my colleagues, Dan Carley, and a bunch of other people I work with around checking these. Again, it's available as a gem. We can just include it in our build process, and we can check, well, is the syntax fine? Is the syntax of our manifests, so our Puppet code, is the syntax of our templates, is the syntax of our YAML files, so our ERB stuff? And again, very quick check that actually, if you were to find out later on it's a lot more expensive, running a very fast process across your code helps. For people paying lots of attention, there's a word break there. And you'll see this lots when you come. And if people are Ruby programmers, they'll be very familiar with it. If they're not, they won't. And I think lots of people forget the tool chain built around sort of like doing anything on top of Puppet. You need a little bit of understanding of the Ruby sort of development ecosystem. So Rake is a Ruby build tool. It's like Make, but in Ruby. Yes, it would be lovely if actually we all just used Make for everything. But it turns out every programming language has to go through a period where it writes its own build tool. There's an advantage here that it's very easy to distribute rake tasks as Ruby gems. So I mentioned sort of the Puppet lint and Puppet syntax, and we talked about RSpec Puppet. All of these are packaged as Ruby gems, basically Ruby packages. And if you've got the gem command, you can very easily install them. And you can then very easily include them in your rake file, which is basically just like a make file, like a build file. It's a command line tool which we can just run. We can run specific commands. Once you've got it installed, understanding it is less important than this. Rake-T will list you out all the commands that are available to you. At which point, knowing that it's rake command name to run them, well, you can run them and see what happens. Especially when it's sort of testing, and like they should come with a description. They should come with a good name. If it says rake lint, you think, well, that's going to hopefully run the linting. Rake spec, it's probably going to run the test. And we can we can combine these together as well. So we can very easily declare different types of tasks that add ones together. So if we had a spec, a lint, and a syntax check running the tools I've been talking about, well, you could wrap those all up as a test. And then you've got one command that you can run that says, is my Puppet code basically meeting the style guide? Is my Puppet code, is the syntax of my Puppet and my ERB and my YAML files actually valid? Is it ever going to work? And then you can say, well, now run my test suite. Is it doing what I think it wants to do? Is it doing what other people have added features that I don't know about? I think it's doing. Unit testing is just part of it. Think some low barrier things like linting and syntax checking again are very fast, but none of this is actually telling you whether the thing that you created works. They're telling you things about your code. That's good, but that's not enough. So nearly on top of unit testing, you'll often find whether it's integration testing or acceptance testing is the word that's being used around a tool called Beaker. So the important thing here is that you're testing against real systems, real virtual machines where the actual real Puppet code has been run and installed packages as installed files. That's not what's happening with RSpec Puppet. It's basically it's doing it virtually. It's doing what the code is meant to do. The reason for that is that it's very, very fast. Because firing up virtual machines and installing real packages isn't as fast. So do fast things that give you some confidence, do slower things next as part of the pipeline. Again, you can see how far you can go with that with Tom's diagram of doom. So again, we're testing what actually happens, not what is meant to happen. Unlike all the RSpec Puppet stuff, actually Beaker is a tool from Puppet Labs. It's very new. So I think if you tried to get official support from them, they'd freak out. But it's coming out of basically, someone mentioned earlier actually, RSpec System. RSpec System was written by one of the Puppet Labs guys to sort of solve this problem. A lot of that's been absorbed into Beaker. So I've done some stuff with RSpec System, but I think the way to go now is with Beaker. I think Ken will tell you that. The thing is here, it's about actually testing against different operating systems. So we can declare that most of the complexity of this tool is basically it's in the tool itself, but we can say, well, here's a config file, ignore the config bit. Basically, I want to test this against an Ubuntu server. The actual role is there's some config details here. Importantly, it's on the hypervisor vagrant. I'm going to use this to test against using the vagrant virtualization tool. But you can, it does support some other bits and pieces I'll come to. But we can have the same config file and swap some of these bits and pieces out. So we can swap it for, in this case, CentOS. And we can run our tests against both of these at the same time in parallel. Obviously, you start needing machines that can fire up be happily running multiple virtual machines at the same time. Your laptop might be one of those, it might not be. And eventually sort of supports actually multiple hypervisors. Because at some point, Vagrant is brilliant for doing if you're doing a few, if you're doing it on a train. But at some point we want that to be a lot faster. And you might be testing, depending on what you're developing, you might be testing against a lot of operating systems. So if this is one of the Puppet Labs supported modules, or if you're doing something similar to that, actually testing that locally is not going to work. There's a bunch of hypervisor support for other things, including VMware. I haven't seen official OpenStack stuff, but it wouldn't be difficult to add. I'd love to see some Hyper-V stuff as well. What Beaker provides are basically helpers to do the obvious things. Given a virtual machine, well, it needs to have Puppet installed on it. I need a way to say, well, these are the dependencies for my module that I want installed. It does. It has little helpers. And these helpers, are, again, basically allow you to sort of go into your code. So basically, they're not going into your Puppet code, they're going into your tests. And there's a Puppet helper for here installing, sort of calling module install Puppet Lab standard lib. Obviously, you can install all your dependencies as part of your test. And we can test that Puppet runs. So when we run Beaker, it's going to fire up one or more virtual machines. It's going to provide some metadata to them. It's going to install your module on them. And here we're basically providing some Puppet code. And we're saying, well, expect apply manifest again is basically saying run that Puppet code. And bearing in mind you've probably already installed your actual module on there. So here we're sort of saying instantiate the fast simple. Well, the Puppet code you wrote is already on there. But the exit code should not equal 1. It should not fail. But we can also test that test runs are idempotent. Everything should happen in that one test run. Does it? Well, let's test. So we run apply manifest once, and it should not fail. We should, if we run it straight after that, well, it shouldn't do anything. It should exit with 0, not just not 1. And that's sort of, actually, even just that, even if you just do that for all of your modules, you know they actually run. You know they run, you know they're idempotent. That's a step forward. Like lots of modules that you download, so actually you have to run them twice, or they just don't work. Or you don't find that they don't work until you've rolled them out to a load of servers. We can do that with Beaker, much nearer to our development cycle. But we can do way more than that. We can actually test that the module actually installs the package, that it actually has that service running. That actually, if you went to the website that you brought up because you installed an next package, that it responds with a correct status code. So Service Spec is brilliant. Service Spec is again a sort of an extension on top of the sort of our spec for writing tests against infrastructure. It's used by Beaker for writing tests against these sort of things that you're bringing up, but you can use it for everything. Have a look at Service Spec, it's brilliant. And the code looks like this. So, again, similar, describe, well, what are we describing? We're describing the Nginx package, and we're saying it should be installed. We're saying, describe the Nginx service, and it should be enabled, and it should be running. Port 80 should be listening. We can write these tests against you could use this as a monitoring tool, but here we're using it to say, we've run some Puppet code, our Puppet code worked, or we think it worked. Did it actually do what we always intended it to do? So you can imagine this being a very, very simple test case for an Nginx module. And one of the things here is basically, Service Spec is abstracting us away from having to know how these are installed in the same way as Puppet does. So this same code can run on different operating systems that use different service and different package managers. It abstracts you away from doing that. So basically, not only can we write one set of Puppet code, we can write one set of tests. That neither of them need to care about the fact that you're on Red Hat or Debian, that you're on SUSE or CentOS. So we've got a lot of testing tools. And a lot of this is sort of like the last 6 months, the last year. The tools have got a lot better. They didn't exist. We can start now adopting them. And I think that gives us sort of unit testing, it gives us acceptance testing, it gives us a lot of the sort of the software development tool chain. But there's more that we can do, and there's all sorts of bits and pieces built on top of these, or that take advantage of the fact these exist. So one of them is actually the Puppet Lab's Spec helper. So there's a bunch of common things you always want to test when you're doing a module. That Spec Puppet is the low level. This is a load of opinionated stuff on top of that. So fixtures, basically when you have dependencies from different Forge modules. Downloading them, making sure they're on the path is sort of annoying, this helps with that. And this is basically Puppet Lab sort of layering on top of something that came from outside their organisation to make it much, much, much more usable. Travis is a continuous integration tool. Basically, it's a free for open source software. It's a software as a service product. Realistically, you could be using, I think someone talked earlier about Solalasim, Bamboo, Tom was talking about Jenkins. Continuous integration you can do anywhere. The nice thing with Travis, especially if you're doing open source modules and you're putting them on the Forge, is this is free and very, very easy to set up. It also looks nice. People can go along and have a look at how, what's your test set? This is one of my modules that's running that test suite. So it's running a series of unit tests. It's running syntax and limit checks. It's running integration tests. And it's telling me via email, telling anyone who wants to subscribe whether something's succeeding or failing. If you're an organisation, you can get this to feed into your IRC room or your HipChat or whatever. Brilliantly, it also automatically can test pull requests. So if you're on GitHub and people are sending you contributions, and people will do if you've got a good module, it will automatically test those and tell you whether or not they have broken something that you did previously or someone else did previously. And all you need to do, the beauty of the Travis in particular is just the low barrier to entry. You provide basically a very small text file in your repo, tell Travis about that repo, and you're done. And we can test it against multiple versions of Ruby. And we can test against multiple versions of Puppet. But actually, Puppet officially doesn't support all possible versions of Ruby and all possible versions of Puppet. But that's fine, because Travis will allow us to exclude the ones that don't. And again, we can share this. This is based on Puppet Lab's published material. So this is the same for every single one of my Puppet modules. If that changes, I will change these. There's a bit of an annoyance I have to change them in a lot of repos, but Puppet Lab can fix that. There's also, and this is something I worked on recently, experimental code coverage support in Spec Puppet. This isn't actually in the release version yet. I think there'll be a release at some point soon. But actually, over time your test suite builds up, and at the moment you've probably got a load of modules where you might not be testing them, or you might not be testing them much. You can start, you don't have to, it's nice when you can start from a clean slate. It doesn't happen very often. You can still go in and write a load of tests, but it's useful to know what you haven't tested, and code coverage is a way of doing that. And support is now in Spec Puppet to do this. And this is back to the Nginx module I touched on earlier, where at the end of our test results, as well as telling us that, well, it passed, it failed, it ran all these tests, we're saying, well, actually there were 24 resources in here, the tests touched a bunch of them, our code coverage, again, people get carried away with sort of the numbers, but the interesting bit really is actually, these are things in that module, that module uses, that get instantiated as part of the graph when you use this, that I haven't tested yet. This is quite good for people who are sort of a bit OCD, because you can go down this list. This gives you a list of things to test. And getting started with testing feels a bit weird if you're not used to it, and especially if you're doing it in isolation or on your own. It's not like, well, what to test? The answer is, well, you'll get much better at that over time, but a tool like this can help with, well, you haven't tested this, so start there. Over time, you'll probably work out that you tested the wrong things. You tested more than you needed to do, but that's a nice problem to have. This is an answer to one of the questions someone else asked earlier, and I think, well, actually, I've just talked about a load of tools, and putting all of those together sounds boring, and it is. And putting those together sounds like it requires actually more knowledge than you would have if you're not a Ruby programmer. Yes, I said you're sort of going to have to become one a bit, but you don't have to become one completely. This isn't like, unless you want to change jobs. So Puppet Module Skeleton is basically something that I put together and a bunch of other people have contributed to, and I know there's a few people who use it in the room. To actually just like put all of this together in one place as a skeleton for people to use. Because actually one of the tools that exists already is Puppet Module Generator. So Puppet right now, unless you're using a very old version, you can type Puppet Module Generate module name and you get a skeleton. Actually that skeleton is pretty basic, it doesn't have any of these sort of testing tools well wired in. It's very, very simple. And that's fine. If I'm interested in that, I'm interested in actually something that's much more opinionated with really good testing tool integration. The hidden thing with this is basically based on a skeleton inside the Puppet code base. But it doesn't have to be. When you run that, the first thing it does is checks whether you have a local skeleton in a file location. It's basically, I think it's like home.puppet/skeleton or something like that. It's basically just like, if you drop files there, it will use that skeleton instead of the one in the Puppet Labs repo. Instead of rather than the Puppet Labs source code. So actually, the installation instructions for this simply say, well, copy this directory to this place on your file system, and then you're running this command and you're getting a much, much more opinionated skeleton. It is pretty opinionated, but it's all set up. It's a good starting point, I think, for learning like how to test as opposed to learning all the tools. It does come with a lot of stuff, but actually getting Beaker setting up and getting aspects of Puppet set up can be a bit of a fact to start with. You should look under the hood at some point, but you might want to try it out first. I think another way of sort of learning, again, you're often not going to do this from scratch, like steal things like from out there already. Shameless self-promotion, but one of my modules that is quite popular is basically the Docker module. And I got access to Docker basically before the public release, so I actually started writing this before the public release. And one of the things that because I got in so early, there's actually lots of people who were about to write one went, oh, well, wait a minute, there is one. And it's one of the few cases where there's actually, I haven't seen this big spiral of like the Apache modules. Like, everyone has their own private Apache module in their organization, and there's about 7,500 on GitHub. There isn't for the Docker module, which I think is pretty interesting. It's actually the featured Puppet module on the forge at the moment, or at least it was a few days ago. But the interesting stuff here is, like, I've had actually more than that now, like more than 50 pull requests from different people across all sorts of different organizations. And instead of them creating their own module, that's 50 Puppet modules that don't exist because of this. And that's lots of people contributing on the same code base. I still have features of it, but actually most of the features now are added by other people. I curate and help that. And as part of that, I put some simple contributing guidelines and stuff, which insist on, the first one is fault the repo, but the second one is run the tests. And the third one is something about tests. And then the fourth one is something about tests as well. And actually, lots of people come along and just do that, which is great. Because some people have been at Puppet long enough. I'm sure Tom's got some code in there. He's going to write some tests, because he was going to write some tests anyway. But actually, loads of people have come along and said, oh, well, I've tried out Docker and I've tried out your module and I use this, and here's a feature. And I've gone, brilliant. But they haven't sent any tests. And I said, well, I need some tests for that. But I've not been like, not including your code unless you start with tests. I said, well, here's some guidance, here's some help, here's how to do it. If you need some help, and I'll happily pair with you on writing some simple tests. And then you go, brilliant, fantastic, you've written some tests. And actually, that's viral. I got some code. This module got better. Anyone can use this module, and someone learned how to write some tests inside an existing code base. And sometimes that's a lot easier than writing something from a sort of there's no test. So maybe the first test you write, if you've never wrote any tests for public code before, actually isn't on your code. Go add a feature to a module that's out there already that has a test suite, not necessarily this one, and write a test for it. And also, if you've got modules out there, insist on tests. It will make the code better, more shareable. I think the fact that I've got a load of pull requests and a big test suite go hand in hand. Part of that test suite as well is that actually this supports a whole bunch of operating systems. I don't use all these. I don't care about all of them. Some people do. Some people added that functionality for me, or for anyone who wants to use that open source code, and run tests for it. Brilliant. If I change anything, I don't have all these operating systems handy, but I do have the Beaker integration tests that I can run, so I know I'm not breaking something for someone else. And if I am, or if someone else is, to an extent, well, there should have been more tests. There's currently 121 test cases in this, which is quite a lot. But actually, as a sort of idea there's sort of 6 classes, 2 defines, 413 lines of Puppet codes, 387 lines of test code. I think from different types of testing, there's no numbers on Puppet modules for this. I looked at this for this and thought, oh, that'd be an interesting scan of the forge. But that sort of one-to-one-ish sort of ratio between test code to code isn't that dissimilar to what you'd expect in a whole bunch of other sort of programming languages. I'd say that's a reasonable sized module with lots of contributors. It supports loads of operating systems. There's a load of options, and that's pretty good. Not all of your modules are going to have that. That's fine. I'd say having something is best. So I've probably gone very quickly, and I'll talk about a lot. And I'll talk about some very simple things that are quite sort of, well, you think, well, applying that's a bit tricky. But it's an introduction. There's a lot more to learn and start somewhere. If you take anything away, just remember that infrastructure is code. That's what Puppet is about. That's what all these tools are about. Is we're taking something that has historically been quite manual and time consuming. We're turning it into code so we can go very fast. In Tom's case, it's because someone will come along and they'll tell your company, I work for the government, so that's not really my problem. But we still really want to go fast, because otherwise, we have to charge you more taxes. So it's code. Learn some software development tricks. It's not about completely changing. It's about taking advantage of 20 years of software engineering and stealing what we can and applying to our domain. We know the domain. The tools now exist to do this well. The first test is by far and away the hardest. Especially if you're doing it on a code base where you've never tested before, you have to get all of that set up. I think things like Puppet Module Skeleton, if you're starting a new module, or going to have a look at sort of an existing module like the Docker one, or like any other one that has a good test suite. If you can check out a repo and install the dependencies and run the tests, have a play with that, try and add another test to that before you do it sort of on getting it all started with your own modules. It's by far and away the barrier to entry to get over. Once you're over it, you'll be like, woohoo, testing's so much fun. For people who are sort of they're going yeah, well, I write tests. I'm already there. Politely, that I should have bold that. Politely demand, so very strong word demand, do it politely. Require tests for contributions. I originally put tests for open source contributions, but actually, if you're inside an organization, whether it's people from inside your team, or people from the development team, or people from anywhere inside your organization that's contributing something that's really useful, say, well, that's brilliant. In order for it not to be broken in the future, let's write tests. And if they go, I don't know how, then help them. If you say, don't want to, well, sorry, that's not being very professional. Have that conversation. Untested code is a liability. Might not be on the day you write it, but it will be the day you run it. And lastly, you'll see this in a few places, test the interface, not the implementation. Lots of people get hung up on sort of Puppet testing because they go, Puppet is a declarative language, and so you end up with this sort of package, this, ensure installed, test, package is installed. That's pointless. Don't do that. Only test the different code paths where you've got ifs, where you've got logic, where you're doing different things based on facts, where you're doing different things based on parameters. Test that. Don't test the innards of your puppet module, test the interface. Because that's the thing that wants designing, and that's why it's I much prefer thinking about test-driven design than development. And that's me done. Thank you. I've got time for questions if anyone has any. There's one over there.
How do you feel about, instead of using beacon testing, actually having a sandbox environment so you can run a puppet on it and then people can actually go to the endpoints and do like acceptance tests about the actual web and
So the issue is just like how long it takes. So whether you can use Beaker to do that. Beaker's optimized for basically setting up multiple things at once. Maybe you don't care about that, but you do care about the time it takes. If someone is going in to click around, that limits how long you, like basically, you want to get the cycle of your code down as far as possible. The moment a person gets involved, that balloons. So how many changes can you do in a day? The moment a person has to click around, the answer is not very many. And in my view, the answer is not enough. Someone will come and eat your lunch. Remove people, if you want to have something, so server spec is really good for sort of doing tests on the innards, if you like, of that server. But maybe you do care about someone actually clicking around on the interface. Well, write that in code. Phantom.js or even Selenium, or there's lots of tools for doing sort of like application integration testing. If you want to tie into that, brilliant. But I think the moment you introduce a person or a single environment that you're sharing between multiple people or multiple teams, your cycle time will balloon. So computers is more people. Other questions? I think we're good.
One more question.
Oh, one more.
Surely someone has one. People just want to get a fast class.
One here.
Axel Puppet is great for testing, but as you have more test coverage and you increase the number of modules, it becomes painfully slow, especially if you have a continuous integration after run. Is there a good way of actually parallelizing those tests?
So the question there is about sort of actually, as you add more and more modules, your test suite gets slower and slower. And I think the thing there is, test the module, not your repo. So actually, if you change something, if you've got a big stack of 100 modules, third party or first party, doesn't really matter, and you change one of them and you run the test suite across all of them, that's going to get slower and slower and you're never going to deal with that problem. Throw hardware on it, it'll get faster. Throw parallelism on it, it will always get slower. Or test your modules independently. So I think if you've got a very big monolithic sort of repository of modules, break that up. Break that up into individual modules should have an individual repository. They should have an individual job on your continuous integration pipeline. They should have individual test suites. What you might then do is, at some point you're still going to have a manifest that says, well, the nodes that match this pattern use these modules. And you can write tests for that independently. And ultimately, you've now broken down if you had something that was sort of like using 100 modules and you had tests for all of that, and that's one test suite, always busted. If you break that down into basically 101 test suites, you can test the right thing at the right time. You've always got this eventual integration test thing. That's probably always going to be the slowest bit, but it's going to be a hell of a lot faster than it was when you were testing 100 other unrelated changes as well.
Is there a way to group test into like a run, say slow test, fast test? So for example, we can say for my normal development, I do fast test, taking it a minute, and then twice a day I run like a big suite. Is there a way to group them somehow? Or?
Yeah. So absolutely, yeah. So the question there was, can you group tests into sort of slow and fast, or even just different averages? The advantage of a load of this tooling being built on top of the RSpec framework is RSpec is a very mature piece of software. All of the sort of things that all the things that you could think of, it probably does. And all of this is built on top of it. The thing there as well is actually you're breaking your test suite down into separate, you have a test suite for each module independently. The document example there, I think runs on this machine, which is underpowered and not my dev machine, runs in about a minute 10 for the Spec puppet and syntax and link checks. So actually, especially if you're using something like Guard, that's never the bottleneck. The integration test suite will always take a while. Doing that as part of the sort of that loop like Guard there, I don't do that. I do that when I'm ready to check in, or as part of a continuous integration sort of pipeline that blocks builds and things. But if you did write a Spec test that was very slow, you could partition it with however you want.
Okay, thank you, Karen.
Thank you.